the language of the universe.
But I don't understand it.
Hello, everybody. Welcome back to the Math and Physics Podcast. I'm your host, Parker.
And I'm Ray, and we welcome you to episode number 43, where today, as you've probably seen the extremely interesting title that we have for you guys, we are going to be talking about the flat earth theory and why, and all the different ideas to why flat earth may or may not be possible. So Parker,
That's
do
right.
you think that we live in a flat earth?
Personally,
Yes.
I don't.
Okay.
That is a personal opinion, though.
Mm-hmm.
Quick disclaimer to everybody.
Yep.
If you do believe the earth is flat, please let us know in the comments if there's anything we missed, any details that could support flat earth theory, and we will surely get back to you, or make a part 2 to this, our famous part 2s that we never make.
Because I think, the thing with flat earth, right, is that a lot of people that are not even really scientific love to hate on them. Even though, okay, I get it, we're going to get into, flat earth mentality maybe, like the person behind the flat earth. But, I mean, at the end of the day, it's simply a different scientific opinion, right? Now, I know, obviously, we have all the scientific facts that we have today. And some people are like, obviously, those people are just wrong. Right, but what's interesting to me about the flat earth theory is that there's always that there's another idea out there that not only is the earth, spherical like we have believed for thousands of years, but now there are these people saying, it's flat. And either, some people say it's ignorance, some people say it's lack of knowledge, but some people just say, it's just a different opinion. And we're obviously going to talk more about if it's actually an opinion or is it really just a fact. But I think it's an interesting idea that people like flat earthers exist.
Before we actually get into the podcast, I'd like to say thank you to everybody for 3,000 followers on Spotify.
That is true.
Very nice.
Very
New
interesting
Year's
too.
Gift.
Yeah, very interesting too. Parker completely called it. I think like 3 episodes ago or something. He's like, we're on track to hit 3K by New Year's. And on New Year's, we're exactly 3,000. Like not even one follower up.
The Spotify analytics update at the end of the day. So technically we hit 3,000 during the day of the 31st.
Yeah, it was on the end of the 31st, right?
And then it updated at midnight. So
yeah.
Anyways.
So that was really cool.
If you're listening to this on Spotify or Apple Podcasts or anywhere else on your phone, make sure to check out this episode on YouTube. It is being recorded right now, and you can watch us talk and use our mouths instead of just using your ears.
Exactly. Always an advantage.
Anything else?
Yeah,
Instagram
a quick, interesting,
quite an important.
Yeah, sorry. Quite an important note right here. So, or not a note, a request for our audience. So, as you might have been able to, or at least the YouTube viewers, if you guys are watching it on YouTube as well, and Instagram, who follow on Instagram and TikTok, you might have noticed that we're now doing these things called clips, right? We started clips, I think, like 2 episodes ago, and the idea is we release a clip every day that we don't release an episode. Right, so like there's going to be an episode, let's say every Monday, then the clips are going to be Tuesday through Sunday, and then Monday is another episode. The thing is, though, it's a lot of fun to do, but I am not necessarily a trained video editor, and I think that is quite obvious because, second-year university physics student out here, not really trained in the editing station. So the request is that I will still be making the video itself, but if there is any volunteer from our audience that simply wants to help out the podcast in its early days, because right now it's simply Parker and I, and a quick shout out to this editor that we have for our audio, Marcel goes by the name M Rock. So shout out to him. But yeah, so if anyone would like to, help out the podcast in its early days, which is right now, and would want to, just have a little bit of video editing experience, we can just, talk, send us an email, and, we can get into some discussions. So yeah, just a quick request.
All right. And as you know, we do run ads on our podcast, but, giving a portion of that to people who want to help us out really is not like anything at all.
It's very sad. Like, it would be worse to give you some of that than to not give you anything at all, because it wouldn't be much. It really wouldn't be much. So
yeah, it's better. Like, for us, of course, it makes sense because, zero is worse than not zero, but, if it's not really any kind of reward. But anyways.
Again, also, like, the experience, I think, is kind of cool because, like, you're literally going to be watching the whole podcast before it comes out, which I think is kind of interesting,
That's
and
fun.
you're going to be able to pick your own clips. And, those clips will then, obviously, like, we'll go into further discussion of what the role actually is. But, like, just any video editing experience, if you just want to help out, that would be great.
All right. So let's get into this episode.
Let's get into it.
So the Earth is flat.
Yeah.
First off.
Yeah. Let's
Clearly, if you look into the distance, right? You get on top of a mountain, you look into the distance. Where's the curvature?
Oh,
I
true.
can't see the
much.
curvature.
You don't see much.
So, obviously the Earth has to be flat, or else I could see that, like, with my eyes, I could see that it's a ball. Mm-hmm. All right. First response. The Earth does appear flat. I will give you that, to the fictional person who's arguing right now. The Earth does appear flat, and so does a lot of things, right? Mm-hmm. But the problem is that grasping the scale of the Earth is very hard to do. The Earth is bigger than you might imagine it. And the fact that the Earth is so big makes it very hard to notice the curvature as a, approximately 1 meter on that scale, right?
Mm-hmm.
1 meter
like
tall.
A very short distance, because, like, well, not
right.
1 meter, like a few hundred meters.
I'm saying our height, right? Like our
size.
Like
our height. Yeah, true.
Yeah,
true.
So approximately on the scale, on the order of 1 meter, it's very hard to see the Earth actually curving with our eyes, even if we are 1 kilometer up in the sky on a very tall tower or mountain or whatever. It's still very, very difficult.
But we would be actually on a 1 kilometer high mountain or a tower or something if we place an object out of view of the person on the ground. Mm-hmm. We most likely, if not definitely, will be able to see it from 1 kilometer up, right? Because we're getting that field of view. So yeah,
that's
so
right.
Also
and that does actually prove or it supports the fact that the Earth is a sphere.
Interesting, very interesting thing right here. The Earth is flatter than a pancake. What? Let me explain. So the idea behind this is, I think it was kind of a joke, because it's kind of obvious that it's flatter than a pancake, and let me explain. Because, again, Parker said, right? Huge. Earth is ginormous. A pancake is like, how big is a pancake? Like maybe 3 centimeters in radius? 2 centimeters in radius?
Nah, what? 2 centimeters?
Yeah.
A pancake, man. Like 10 centimeter diameter.
4 centimeters?
At least.
Maybe.
Sure.
Maybe 4 to 5 centimeters in diameter.
Does not matter.
Anyways, the idea is the pancake is about 4 to 5 centimeters in diameter, and the Earth is about 7,000 kilometers in diameter. So when we blow up the pancake to the size of the Earth, if we were to see the small ridges that are on the pancake, right? Like, because obviously no pancake is perfectly flat. There's obviously some ridges, right? When we expand it out to, let's say 7,000 kilometers of a radius, the largest, kind of, how do I say this? The largest depression, or like the largest, what am I trying to say? Like,
like on the pancake.
Yeah, like on the pancake, you know what I mean? Like
Yeah.
there are different different ridges. The largest ridge will be tens of hundreds of times larger than Mount Everest. So the idea behind this, this kind of a joke, but now it's being taken kind of seriously because at the end of the day, it is true. The Earth is in fact flatter than a pancake, even though it's not flat. Because a lot of people took this statement and then they're like, oh, the Earth is flat. Well, no. All this is trying to say is that, things at big proportions, that, things that the size, the magnitude scale of the Earth, we can't compare that, or we can't, characterize things about that with our eyes. Because we can't see enough to truly grasp what is happening on this ginormous level. 6,000 kilometers of diameter, and we're not even a meter, we're 2 meters tall. Our vision cannot encompass the idea of a spherical
6,000
Earth.
kilometers.
Sorry?
You said meters.
Sorry? Yeah.
You said 6,000 meters.
Oh, I meant 6,000 kilometers. Sorry, I meant 6,000 kilometers of an Earth radius. So it's, as I said, it's just a lot bigger, and simply we can't understand that scale. So, we're like, oh, the Earth is flat. Ignorance.
All right.
Anyway, let's
So,
continue.
one thing I wanted to talk about, and you can also Google an image. Well, you probably already know what it looks like, but the image that flat earthers use, the disc with the map on it, right?
Yeah.
So I do have an issue with that, of course.
Okay, let's hear it.
This might help visually if you have an image of it in front of you, right? But okay. So the point from like South America to Australia, right? If you draw, like, the shortest path would be to draw just a straight line
Okay.
on that disc, right? And that line passes through the North Pole. Okay? So,
Oh,
right.
I was so confused. So it's to Australia. So you're going like over.
Yeah.
Okay. Because
Yeah.
I was like, what line?
You
are
just
you
go
doing?
in a straight line on the disc,
Yeah.
right?
Continue.
It would just be, you'd go through the North Pole, okay? And so, if you look at the spherical Earth and you look at the shortest distance from South America to Australia, you'll see that it goes sideways, right?
Yeah.
That's the shortest distance. And so if you take that line that goes sideways and you put that onto the projection onto the disc, it is much longer than the straight line.
Of course.
Okay.
Right? Yeah.
But this is like a real experiment that you can actually do right now, okay?
Okay.
If you want to take a flight from South America to Australia, let me get to the point here. You are not going to pass through the North Pole.
That is a true fact.
Even though it's the quickest way, right? Even though I don't think there are direct flights from South America to Australia.
Probably
but all
not.
I'm saying is that even though it's not a direct flight, you're still not going up through the North Pole and then back all the way through to Australia. And if that's the shortest way, then why isn't that how we go to Australia? Also, this also works for tons of other places. Like you could take a straight line directly to that place, but why do you take a seemingly longer path to get to that location? So that's kind of, that's one way where I just can't wrap my head around having a flat Earth. Like, why are we going out of our way, taking longer routes when that makes no sense? Unless you have the argument, which I think is completely ridiculous, to say that, the government wants you to think that it's routes, so they specifically don't go through the shortest path or whatever.
Don't even start with that. That one is okay. I think that argument is a little like just misleaded. How can you think that? I mean, I guess if you're like a huge government hater, I guess see you thinking about governmental conspiracy theories that they're out to get us and we do live on this flat Earth. But why would the government want people to know that we're in a flat Earth? That's what I don't see the
point. I don't see the point.
What would be the point of convincing people of that fact? I mean, at
I
the
don't
end of
know.
the day,
Like,
if it's spherical or if it's flat, that won't change how people live on it.
yeah, and either
So
way,
what does
we're
the government
trapped.
have to gain from that? Yeah.
You know, like either way, we're trapped on the Earth, so it
Exactly.
doesn't really
Exactly.
change like the psychology.
So
Like,
why would
if it
the
was a debate,
government have anything to do with wanting this is the one argument that I just hate when people bring up because they're like, "Oh, the governments are just against us." But like they have nothing to gain from a flat earth or from a curved earth. Like
yeah,
what is
yeah.
there?
I think if the debate was like whether the Earth was like infinite, like if it just went out infinitely, or if it was restricted, that would be like psychologically different because it's like, oh, if at any point I want to go like run away, I can just go like in some direction. But
And
if the
never come back,
government
yeah.
wants you to think that it's restricted, then it's kind of like you're stuck here, and like you like it changes your psychology.
That's
But either
definitely an
way,
interesting.
like,
I mean, that's like a conspiracy. That's another like a thought,
yeah.
right? Like, what if
I'm
they're
not
hiding
saying
it?
the world is
Yeah, yeah. I mean, we're not
infinitely
saying
flat,
that at
by the
all.
way.
Of course, of course.
I'm
But
just saying if that was the debate, then it would be completely different, and it would be kind of viable to be like, oh, maybe the Earth isn't like restricted to a disk because they're trying to, I don't know. Anyways,
other thoughts or other first appearances or evidences of the Earth being spherical was could be thought of all the way back in, I think, like around, what was it, like 300 BC when Aristotle was there. When was Aristotle there? About 300 350 BC.
yeah, I think
right?
so.
And Aristotle, so there was, I believe it was Pythagoras. I'm pretty sure it was Pythagoras who first came up with the idea that the Earth is in fact a sphere or is like round, right? Because no one really, I guess, cared or even thought about that, but at that time. But then Pythagoras was like, hey, it's round. But he gave no evidence. He simply said, because of, I think it was something to do with, religious beliefs and something like that, that tied into the fact that the Earth had to have been round. But then, hundreds of years later, because I think Pythagoras was like 500 BC. So like this is like 150, 200 years later, when Aristotle shows up, he has evidence, or at least kind of like physical evidence, that the Earth simply cannot be flat. One major point was constellations, stars in the sky. Like in one place, you see different constellations in different locations than on another place on Earth. And he did this, I believe he was in Egypt when he was doing this. And I think he just went to different places and he saw different constellations and he came up with this conclusion that it simply can't be flat, right? Another very famous one is the ship, like oh, sorry, you want to say something?
Oh yeah, I just wanted to allude to
Yeah, because I know you have a
our
star
episode.
point. Yeah.
Yeah, our episode on called QED where we talk about proofs real quick. I just wanted to say, like, using the proof technique, right? The if-then statement, right? So I'll assume one thing and prove that a contradiction and say, well, therefore it's not true. Okay, so let's assume the Earth is flat, right? Then at any point on the Earth, if you looked up at the sky, very distant objects would be like relatively in the same place, right? So one constellation that if you're facing north on the flat Earth, you look up, you'd be able to see some constellation. If you're anywhere else on that Earth facing north, you would be able to see that constellation above you, right?
Exactly.
But this is another experiment you could do right now. If you're in the northern hemisphere, you can see the North Star. You can look at it with your eyes and say, oh, okay, well, that's the North Star. You can then take a plane or a boat. You can go down to the southern hemisphere, and you'll see that you can't see that star. If the Earth was flat, right, the North Star would always be above the flat Earth, no matter what.
True.
Unless you're arguing that the flat Earth rotates. Anyways, that's not the point. The point is that once you go to the southern hemisphere, the curvature of the Earth, right, makes it such that the Earth is in the way of the star that you're trying to look at. And this works, of course, with any other star, right? When you're
any constellation too.
Yeah. And this also doesn't work, proving again that the Earth is spherical. This doesn't work for stars that are aligned with the celestial equator, which is just if you were to project a ball around the Earth, that like projection of all the stars is like the celestial sphere, and the celestial equator is just a slice from the equator of the Earth. This point that I just said doesn't work with the celestial equator, because as the Earth rotates, you're always getting like a panned view of every single star that is along that point, right? So if you're on the equator and you look up above you, you see a star. 12 hours later, you're going to see a star that's on the other side, and then 12 hours later, you're going to see that same star again, no matter where on the equator you are. Okay? And this is my last point. I'll let you continue after this. It also turns out that when the Earth rotates around the sun is going to be in the view of other stars that are behind it, right? And so if you're at some point in the Earth's orbit, you pretend the sun isn't there, but you look towards the sun and you see a constellation on the background. And then 12 hours later, when you face the other way, you'll see that there is a different constellation. Let's say constellation 2. The first one is constellation 1. Now, 6 months later, when you're going to be on the other side of the sun, you can look at constellation 1 that is going to be in the nighttime, and then 12 hours later, you won't be able to see constellation 2 because the sun is going to be in the way. This is just another experiment that you can do on your own.
I mean, you gotta wait for 6 months, though.
Yeah, like you gotta wait, but it's still something you could do.
So those are really good points on, the starry sky and how Aristotle kind of thought about or concluded that, the Earth just can't be flat using stars, because it was it was seemingly obvious to him, but, had to be explained. So the other idea that I was talking about was how ships appear from the horizon, right? Like they don't simply come up, like, right? It comes up slowly. It looks as if it's almost emerging from the water, right? Like in this case, or if it's like leaving, it looks as if it's kind of like slowing down or like kind of getting smaller as time goes on. It doesn't simply disappear, right? And that also right there can be a very obvious fact to why it can't be flat, right? Or why it has to kind of be round, because a round Earth supports the idea that, the hull disappears first, the hull of the ship disappears first, and then the sail disappears absolutely last because it's the highest peak, right? So he thought of this all the way in 350 BC. So this guy knew things that people don't know in 2020. It's kind of sad. But anyways.
And there are arguments, by the way, that I saw on YouTube saying that, there's a video on YouTube that says that argument is not true. Because when you zoom in, like some guy had a camera and he showed the boat disappear, and then he zoomed in and you could see the boat again, right? Okay. And he's like, okay, this is just an optical illusion.
Yeah, because of the water. Yeah,
but here's the thing. This same argument, right, ties into a lot of other issues, such that, it's pretty much the same argument, but used in a different setting. Like, for example, if you were on top of Mount Everest, right? Why is it that you can't see the entire world? Right? Like, let's say it's a perfectly clear day. True. Perfectly clear. Like, why can't you just see there's nothing in the way. Why can't you just see all the way into a different country, across the ocean? Like,
exactly.
I don't know. I mean, an argument could be like, oh, your eyes just aren't that good, but like, okay, bring a telescope, bring tools.
You won't no matter what you literally won't.
No matter what you bring with you, doesn't matter. It's just not physically possible.
And by the way, that point that I mentioned, I think I should explain a little more, because you said he zoomed in like with a camera and he saw it, and then I said, because of the water. So let me kind of explain. So the water creates kind of a mirage effect that, because water refracts light, and the way heat and hot and cold air condense on water, in the fact that hot is at the bottom, like hot always falls and cold always rises. So the idea is wait, that's not right. Cold always falls, hot always rises. Because I was
And
brain
interestingly
glitch,
enough, by the way, interestingly enough, Richard Feynman talks about this in his book QED, and how the reason why you see these mirages is because light travels slightly faster in cold air.
Yeah.
And so the light particles that are in the atmosphere, and light takes the shortest path possible, right? And so the light particles, or the photons that are in the atmosphere, will actually travel from the hot air and kind of dip down into the hot air and then into your eyes. And so it'll kind of cover up things that are far away because the light particle is dipping down into the cold air and then into your eyes. I'm trying to explain something that's very complicated.
Yeah, I mean, it would be a lot. It would help a lot with like a picture or something like that for sure. I can definitely see it. But
and
sorry, that was a small mistake that I made. But also a quick, if you heat something up, like if you have fire. If you have flames, and you know how sometimes you have that blue flame because it's really hot and your orange kind of disappears? In those cases, when your region is not fiery, like you don't see orange flames and stuff, you will literally see the air distort, and the air will keep distorting. And the reason that is happening is because light is refracting through that hot air. And this happens, again, because of how hot and cold are arranged on top of water. And also a similar argument was made, I believe, I don't know when, but where this person took a picture of the skyline that was hundreds of kilometers away. And he's like, Earth is flat because I can see it. But the answer is simply this is all being refracted by this hot and cold, this temperature differential and the water, and we are being able to see it simply due to that fact. It can be explained via physics. It's just that sometimes people don't want to understand it. So I think a line that I said before the podcast that I said I would mention that I didn't. What did I write down? Oh yeah. Just because you don't understand it doesn't mean it's not right. And I think that's a pretty big thing when we're talking about this entire topic, right? Flat Earth. Like a lot of people simply don't understand, like they have questions, and to have questions is exactly the scientific method. Have questions, get them answered. But the thing is they have questions that sometimes have complicated answers. And so because they don't understand those answers, they simply think that it's wrong and that can't be possible. But that's the whole thing. Just because, your brain, I guess, can't grasp it because you haven't learned, 3 years of physics or something, doesn't mean that all that physics is wrong. It just means you might not understand it. So I think that's a important point that I wanted to bring up.
Yeah. Next thing I wanted to actually say was Antarctica, WTF. What is going on here?
The thing around it, how it's like completely around the Earth. What even is that?
Yeah. So, okay. According to the Flat Earth map, Antarctica would be the most massive body of land on the entire Earth.
Literally, it's completely on the circumference of the Earth.
Yeah. So one thing I wanted to say, first of all, is that people have been to Antarctica.
True.
People have drawn, they've been around Antarctica and they've drawn what's it called? The border, I guess. Is there a word for the...
I don't know if that's the word for it.
Like the border of a country with the ocean. There's got to be a word for that.
Oh, there's 100% a word for it. I don't do geography.
They drew like the shape of the country.
Okay.
And people have also been to the South Pole, The
South Pole doesn't exist, right? In a flat Earth, right? No.
No.
Like there literally is no South Pole. So what do you do?
And so, I don't know. People have been to Antarctica. People have seen that it's not like a border of the disc, and it's a shape like what am I trying to say, like a concise, like
it's an island, like basically it's a huge island.
It's an island.
It's a huge island. That's the whole thing.
And basically this also begs the question of where is the edge.
True.
You can go to Antarctica. You can book a flight to Antarctica and look for the edge. Save you some time and money.
No. You cannot book a flight to Antarctica. I swear you have to like take a... Can you take a flight?
Yeah, you can take a flight. They have an airport. Yeah, I don't think it's very easy.
I didn't know that.
Like you can't just like book a flight like online or something. Like you have to like do something with the government and be like, because I think there's like one flight per 6 months that goes to Antarctica. So you gotta be set up with the whole the whole Antarctica flight schedule and all that stuff.
But also, if you
But
think
you-
about it, right? Like the way it's kind of arranged, doesn't that mean that any way you go, you will
Yeah.
you will find Antarctica? Like
That's
how does that make
actually true.
how does that make any sense?
That's actually true. Any direction you go, and you'll find
Like
it.
you'll just be in Antarctica. Like
Technically,
yeah,
that's also true, but you have to go south.
Yeah, I mean-
anywhere you are on the ball Earth, if you go south, you'll
you
find
won't see it
Antarctica.
exactly.
But
But that's the thing. If you're saying going out on a flat Earth is
Yeah.
going south and going in is going north, then what would like going left?
I
and-
don't know.
Would that just
there,
be?
there are also some issues with like the magnetic field of the Earth.
Yeah, the magnetic field, the
'Cause-
gravity, man. The gravity is also
Yeah,
a
of
very big
course.
issue when we're talking about a flat disk. Like, how does gravity work in this case?
Yeah,
Like, you know,
but
a
I
lot of
wanted to
people say it's just accelerating, right? Like through
Yeah.
time.
I wanted to say earlier that, like, okay, no one has ever seen a picture of the edge. And people might say, oh, we've just never been to the edge.
Mm-hmm.
Well, let me say one thing, okay? We have devices called satellites, right, that orbit the Earth.
True.
They have been all around the Earth many
is true.
times, right? Every single corner of the Earth, let's say, they've seen. And so you might be thinking, okay, what if those satellites are just going around in circles above the Earth, above the flat Earth, right?
Mm-hmm.
And all they see is the land part, or the water and land part. Well, it's like, okay. Well, then you're telling me that the way we got those satellites into space, into the Earth's orbit, was completely based on mathematics and physics, right? Like equations in physics that have nothing to do with a flat Earth and
That is true.
everything to do with a round Earth, right?
Mm-hmm.
Every single thing, every single like concept related to orbits and satellites
Exactly.
takes into account that the Earth is round. So you're saying that, okay, we set the satellite out into space to orbit, and then it just completely defied all of our rules and is now rotating in a flat circle above the Earth. Like, I just can't see that. And then
Yeah,
now,
and-
okay,
yeah.
even further than that, you might say, okay, well, satellites are bullshit. You can open your phone, go on Google Maps, and use the GPS. Where do you think that comes from? You can use your data on your phone. Where do you think that comes from? You can also see a live stream on YouTube from the International Space Station, which is not fake, by the way.
How can that even be fake? What?
It's not fake.
Not-
A lot of people say that's fake, but it's not fake, and I promise you. I'm sorry, I'm going on a huge tangent right now.
Yeah,
But people who
it's
say
good. It's good.
people who say that the International Space Station is fake, please buy a telescope and please go online, search up location of the space station. They will give you a
No,
map.
but
okay?
it's extremely hard to do it with a telescope. Like,
It's
believe me,
hard.
like we've tried. Like, it
No.
goes so fast.
I know. It's very hard, but if you buy a very good telescope, okay, very very top tier, you Google, you'll see the path of the space station,
And then you can
right?
just put it where it will
It looks
be.
like
and,
it looks like a sine wave, but eventually, with time, it'll pass over your city, okay?
Exactly.
And you will be able to aim your telescope exactly where they say it'll be, and you will see the space station.
I mean, again, it will whiz by you exceedingly fast because it
Very
is
quickly.
very low in orbit. It's like low Earth orbit, like LEO.
Mm-hmm.
So it's like 250 kilometers, which is very, very, very low.
It's 460 kilometers.
460, sorry, so 250 miles maybe I was thinking. So like about 450 kilometers. But yeah, so those are that's very low. So it's still going to be whizzing really fast. But again, further proof of how, the ISS is complete proof of also how we have a round Earth, right? Continuing on to talk about just flatness, because I was talking about Aristotle. I kind of want to continue on to the first, not really proof, actually this is pretty much proof, the first calculation, the mathematical calculation of the circumference of the Earth. Now, this is a very, very famous experiment that, I don't know, some people might have heard of. You might have heard of this,
We talked
philosopher.
about this,
No,
actually.
not philosopher.
We talked
Mathematician.
about this in the astronomy
No, he's
episode.
he's not a mathematician, is he? He's basically.
Can you hear me?
Sorry, what did you say?
Can you hear me?
No, wait, hold up. Sorry, a little technical difficulty right now.
Hello?
Hello.
Can you hear me?
Yes, I can. Yes, I can.
Okay. I was
Okay,
saying
sorry, you
we
were saying?
talked about this in the astronomy episode.
Wait, we talked about this
The-
experiment?
Yeah.
Oh, well, so maybe I can just give a brief rundown. So
Yeah.
Eratosthenes, a Greek mathematician, was around. This was around I think 240 BC, like 200 BC. This was like 100 years after Aristotle as well. Now this guy is kind of like a living genius. Like when you have no technology, and this guy calculated the circumference of the Earth using a stick. And I think this is probably a pretty popular statement, where this guy can do it with a stick, but people still can't figure it out now, right? So what he did was, are you sure we explained this in the astronomy episode?
Yeah, we explained how they calculated the diameter and the distance of the moon, and also how they calculated the size of the Earth. I'm pretty sure.
But we didn't talk about the circumference experiment, did we?
I mean, the size and circumference is the same experiment.
Oh, okay. Okay,
'Cause
so
if
again,
you assume
basically
it's
the idea was to find the length or the angle of the shadow given by a stick, because he took a stick, right, on summer solstice. So by finding the angle that, is that the stick makes with the ground, that the shadow of the stick makes with the ground, by finding that angle, we can make kind of like a proportionality relationship between two cities. So if we have the angle, right, of the shadow in two cities, and we have the distance between these two cities, we can simply compare them, because we know the total angle has to be 360 degrees, right? Because again, all the way in 200 BC, these guys knew it was spherical and round, but anyways. So by taking this angle over 360 degrees and comparing it to the distance, between these two cities that the angle was taken on, we can then kind of get an estimate of the circumference of the Earth. And I believe that this guy, almost like 1,500 years, no, 2,000 years before we get the exact number using satellites, he calculated the circumference of the Earth with, I think, only like 800 meters or something uncertainty. Like incorrect from what we know today.
No, I think we were able to find the actual value before satellites.
Were we?
Yeah,
Like the exact?
definitely.
Okay.
Not the not the exact.
No, that's what I'm saying. The
value, but
exact
like
value can only be determined by
No, but
observation, right?
We were able to find it very, very accurately before satellites.
Okay, but basically, again, the point I'm trying to make is that I'm pretty sure those guys didn't do it with a stick, right?
Yeah.
So like this guy did it with a stick, and I think that's
Yeah,
very
literally.
commendable that he found
you can
the circumference of
actually-
the Earth.
You can actually go on YouTube and you can find somebody that does this experiment with his bicycle.
Oh,
He measures the shadow
okay.
on one day, and then like he measures it, and then he goes on a bike ride, a very, very long bike ride. Like I think it was like 24 hours or whatever.
Oh my.
Well, he didn't bike the whole time, but
Okay.
like an entire day passes, right? And then I don't know how many kilometers he goes, but on the next day at the same time of day, he measures the shadow, and then he checks like how far he biked, and then checks the difference in the angle, and then calculates the radius. And it was actually not bad. Like it wasn't bad.
Exactly. I mean, it gives you a very good number. Because at
Yeah.
the end of the day, the Earth is not perfectly spherical. Like there were a lot of assumptions that even Eratosthenes made that simply aren't really true. Like, for example, the two cities that he was working with were Cyan and Alexandria, also in Egypt. Now, the assumption that he made is that Alexandria is perfectly north of Cyan, which I believe is not exactly true. Another one that he made was, that Cyan is perfectly on the Tropic of Cancer. So on summer solstice, the shadow will be 0 degrees, but that wasn't exactly true. So there were these small, exact quantities that obviously he probably couldn't even measure at this time, but he still got a very, very, very close value, and I think that's extremely cool. Another thing I wanted to...
Absolutely.
Sorry, you want to say something?
Go ahead.
Another thing I wanted to talk about was, making bridges in reality. So there's this bridge, that connects New York City and Staten Island, the Verrazano Narrows Bridge. I don't know, maybe I'm not pronouncing it right because I'm not from there. But so the Verrazano Narrows Bridge, right? It's a very long bridge that's connecting these two cities. And the construction took into consideration Earth's curvature. So the towers, like the peaks of these of the bridge, right? Because there are two kind of towers that are connecting the whole bridge. So the peaks of these towers are 41 millimeters farther apart than their bases. So I don't know. If you're watching the video version of the podcast, I guess you can see the kind of thing that I'm making. So it's kind of a little bit like a V almost. And again, that's taking into consideration that the Earth is in fact curved. Because if they didn't do that, then the bridge would simply, not work very well. Even though 41 millimeters doesn't seem like much, it's a big engineering difference, right? And the average curvature of the Earth that we kind of know today is about 8 inches per mile. I don't know why it's in American units. I guess you can just convert that to metric. I just took it in this. So 8 inches per mile is the known curvature of the Earth, and that's kind of what we deal with.
Very nice.
So that's also why, at the top of Mount
is,
Everest, you can't see the entire world.
I'm also guessing this is like if you were to draw a straight line and you'd make like a right angle triangle, like a mile out would give you an 8-inch difference.
Yeah,
at the end of it.
Exactly. Yeah, that's the whole thing. Exactly. So you draw like a straight line, and then 8 inches below it in a mile, you'll see it dip a little bit.
Except that's a first order approximation, right? Because if you were to go out 10,000 miles, it would be infinity.
It would be infinite. Yeah. So again, right? So that's the whole curvature argument. Like if you go out, infinite miles, you'll have infinite curvature, kind of showing that it's, curving in on itself. Right? And
absolutely,
another big point that we didn't really talk about is seasons.
Yes.
Seasons aren't really a thing if the Earth is flat.
Yes.
Right?
And we actually discussed this.
Oh, we did?
No. And I'm saying in our astronomy class.
Oh, in our astronomy class.
We had one of our very first problem sets in our astrophysics course, right? It had to do with the flux received from the sun that the Earth sees. And I think we talked about flux in our astronomy episode series.
Yeah, for sure.
But basically, we tested the difference in the flux being received at a certain point on the Earth based on whether the Earth was close to the sun or further away from the sun on its orbit, so the perigee and apogee, versus the inclination. So whether you are directly facing the sun or you're facing away, because the Earth is on an angle, so if you're on the summer solstice, you're facing directly towards the sun, and the winter solstice, you're facing directly away. And so we calculated the different values of the flux, and it turns out that the flux you receive from the sun changes drastically based on the inclination of the Earth, and doesn't really change at all based on the difference or the distance differential, right, between the closest and the furthest point on the Earth's orbit from the sun. And so you can actually calculate the flux, and you can relate this to temperature on the Earth, and you'll see that what am I trying to say here? We were talking about seasons. Right. You can actually see that during the winter, this is assuming, right, that the Earth is spherical and it rotates around a very big sun. And so during the winter, it'll be at the winter solstice because it's pointing away.
Yep.
And during the summer, it'll be pointing towards.
Yep.
And this kind of violates every single law of flat Earth theory.
Mm-hmm.
Because for seasons to occur, I don't know how you would explain this with using a flat Earth. The only argument I think I've heard is that the sun is actually just very small and very close to the Earth, and it's just the small difference in, like, okay, during the summer it's a little bit closer, in one location
Yeah,
than it is
but-
to another.
So with the small sun, interestingly enough, like the flat Earth theory is that the sun is actually kind of rotating above the Earth. So the Earth is bigger than the sun. This is such a stupid
Yeah.
theory, man.
I know.
But like, I guess it's an idea where the sun is kind of like a small ball that's rotating around
Okay,
the
I do
Earth.
have an issue with that also.
So stupid.
So we are assuming the Earth is flat here, that the sun is rotating around the Earth.
Mm-hmm.
Now, even more than ever, right? I want you to explain why can't you see the sun at all times? If it's rotating above the Earth, why can't
Exactly.
you see it when it's far
Right,
away?
you can always see it.
Like, explain night and day.
True.
Is the sun a spotlight?
I think so. I
spotlight.
think that is the theory that people use, though. When they're describing the sun being like smaller than the Earth, I believe that's exactly how they describe it. Like the sun is a spotlight and there are different parts. But again, that just can't be possible because we have literal observations and, calculations of, energy received and stuff from the sun that just wouldn't make sense if the sun is so
My
small.
head hurts from this explanation.
It's hard. It's hard. It's definitely hard.
Okay,
But-
hold on.
So not only talking about seasons not occurring, but also talking about seasons in different locations. Because I think, remember this, when it's winter in America, in North America,
Yeah.
it's summer in Australia. How would that be possible if we are on a flat Earth? Like that would not make sense. So there are a lot of things that simply require a round Earth, a spherical Earth, to simply describe basic phenomenon that we see, but simply can't be described with flat Earth. But still, theories can still be discussed. So
One thing that I definitely have to mention
okay,
on this episode is the fact that we observe, for example, the moon to be a sphere.
Mm-hmm.
You cannot debate that, and I don't think flat earthers.
I don't know. Do they believe that
argue.
the moon is flat too?
I don't know.
Like,
I
that's
don't think.
pretty
I don't think
ridiculous,
that. I don't think that is a topic of debate.
right? Okay.
I also think that flat earthers also agree that other planets are spherical.
Wait, so they agree other planets are spherical?
Yep. Because
Wow.
you can see that other planets are
So
spherical.
Earth is the only one that for some reason is flat.
So to deny the fact that other planets are also to deny the fact that other planets are spherical would be to just deny absolutely everything we've done since the 19
19, 16, 15, with telescopes and observations.
Okay,
all
well,
the
we
way
didn't
dating
really
back to 1600s when
No,
they
I'm-
witnessed
I'm
Uranus.
talking about like space travel and like pictures, like actual pictures
okay.
that
Talking
we've
about like
taken.
physical Okay, that's different. That's
So I'm talking like since the moment we were sending like probes into space
Mm-hmm.
to take pictures of galaxies and planets and
Mm-hmm.
comets and whatever.
no, but
Ever since that point, it would be saying that everything we've done from that point on is absolutely fake.
because
Like,
if you
we've
think
taken
about it, though,
pictures of
like
Mars.
the flat earthers that have the idea that the Earth is flat are also probably believing that the probes around the Earth, like all of the Earth pictures, are fake,
Mm-hmm.
right? And if they're believing that all the probes around the Earth are fake, they're probably also believing that the probes around the other planets are also somehow fake, right? So the pictures are all made in Photoshop, and we then send them out.
I just don't understand. Like, one thing is, okay, you can deny space travel and all that stuff, but you can't deny the phone that you're holding in your hand, okay?
It's true.
Your phone, coincidentally enough, uses processes that require the Earth to be flat, okay? There isn't like...
Wait, what?
Well,
Wait. You mean round? Wait, what did you say?
Right, round, sorry.
You just said require the Earth to be
Sorry.
flat. I'm like, hold up.
Require the Earth to be flat. My bad.
No, to be round.
I mean round. There's too many flat and rounds
okay.
in this
Continue.
episode. Okay. I'm arguing for a spherical Earth. just to be clear. So there are processes in your phone that require the Earth to be a ball, right? Things like I've mentioned before, like GPS and all that stuff, and there are also very indirect connections that rely, and it's not even your phone, it's pretty much everything around you, right? Like, I'm trying to think of something very obvious that everyone has. Do you know an example? Well, for example, a compass. That's one thing.
Well, a compass gonna be explained with a flat Earth, though.
Except the fact that you need a spherical, like the magnetic fields of
Magnets
the Earth.
don't work. The magnetic fields don't work. Yeah, but I guess a compass.
Yeah, but a compass is based on the magnetic field.
Yeah, but if we're assuming, because I mean, bro, when we're saying flat Earth is a possibility, we're making so many assumptions about the magnetic field, gravity, and we're just saying, okay, let's just take it as it is. Let's just say the North Pole is here. Let's just say the South Pole is here with no real proof because it's wrong. But we're just trying to just like entertain the theory. So I guess the compass, if you're just assuming the flat Earth, it would still work. But you're right, the magnetic fields would just, I don't even know how they would work.
Because it doesn't make sense. Wouldn't. The magnetic fields are based off of the inner Earth movements. We're talking about like the core moving around and creating the magnetic field that goes from south to north. Is that how it goes? Yeah, south to north because of the northern lights. And are there lights in the South Pole?
Yes, there are also southern lights.
There are?
Yeah, there are.
Okay.
No, the lights are simply caused due to the electromagnetic radiation, right? With high levels of magnetic interaction. Because at the poles,
they come from the sun.
Yeah. It comes from, of course, from the sun. But the poles have such high concentrations of magnetic fields that when light at the end of the day is electromagnetic radiation. So when it interacts, it produces different wavelengths and it scatters it at different wavelengths that we can then see as northern and southern lights.
We'll talk about northern lights. Northern lights another time.
So again, magnetic field lines would not be possible. Sorry, I was just doing a quick search and. Yeah, I was thinking about it. Yeah, it's north to south. It's not south to north. Because you said south to north, and I'm like, I'm not sure.
I don't know.
Because I'm looking at a picture, and so it kind of goes out of the north and comes into the south.
I always get confused because of when they switched it, right?
Yeah,
like at some point they switched it.
The Earth's poles, like the magnetic poles, not obviously the physical poles, switch sides, literally switch sides, which again... Like and that happens I think once every some 12 years or something. I don't know.
I don't know.
Some number. I could be completely wrong in that number, but some amount of time interval, and these magnetic poles switch, and that's simply a big of how magnets and how the Earth is producing the magnetic field, and that's perfectly normal. That's not a weird thing. It's just you can't explain it with a flat Earth. You can't explain magnetic field switching with a flat Earth, because if we're talking about a disk being a magnet. Right? I mean, magnetic disks, we know one side is north and one side is south. So if the whole thing is north, like, okay, this is so weird to even explain. Like, how would that even work? It's just hurting my brain.
But technically for compasses to work, the edge would have to be north and the middle would have to be south or the opposite or whatever. Because it has to point towards the middle of the disc at all times.
Yeah, so then it would be so it would point to the center being north, right? Like the center would be north, right? In a flat Earth.
But there are a whole bunch of unanswered and holes in that explanation where it's like, okay, let's assume the edge is south and the middle is north.
Like there are so many
assumptions. How would the disc produce that?
Yeah, like
how would that be naturally produced?
That's what I'm saying. There's no evidence. There's no physical. There's no mathematical evidence. I think that would be step one. If we can't observe something, prove it to me mathematically, because that will convince me probably more than observing something, maybe. So the idea is, if you can prove it mathematically, I guess it's a topic of discussion. But there's no way that can be done. There's no way. So the entire idea of a flat Earth is just lost if you can't prove it mathematically, right?
Anyways,
that's the whole thing.
I hope any listener out there that does believe in the flat Earth
Now
has
doesn't.
been convinced otherwise,
Yeah.
if you do still believe in the flat Earth, please leave us a comment, and we will address all of your concerns and doubts. We will do our research. We will provide
Absolutely.
mathematical proof, scientific proof, observations, and explanations for anything that you deem to be fishy. Because the real people, I think, like, you can believe in flat Earth if you have reasons, right? But if you are presented with explanations that make 100% sense to you, I think it's reasonable to switch your ideas. No one's going to blame you for it, right? No one's going to be like, oh, you switched on your beliefs. Nobody cares, right? No one cares what you believe in. This is for your personal gain,
Exactly.
right? To enlighten yourself. If you have any doubts, any questions, make sure to let us know.
Because I know that there are some really good, okay, good is the wrong term, but there are some solid arguments that are for flat earthers. And we obviously did not cover all of them. There are pages and pages on the internet where it's like, 50, 100 reasons why the earth is flat and all that kind of stuff.
But it also turns out that every single reason has an explanation.
Of course, that's exactly what I'm trying to say, right?
And it's not just
reason has an
coincidental
explanation.
either. It's not just like, oh, here's an argument, here's an explanation. Oh, what a coincidence. Physics always has an explanation. It's not coincidental. It's
Like-
it fits into the framework that has already been established. And every argument just, you can be like, oh, well, this has already been explained and here's why. And anyways.
So
we are
if
coming
you
up.
are a flat earther and just got convinced, or are a flat earther and have a question, be sure to let us know in the comments or by sending us an email. Because we reply to all emails now. We always did.
We always have.
We always did. I will admit, and I think I do need to say this, there are some comments and some, like Instagram messages, like DMs and stuff that we might take some time to respond to, because some of them are some hefty questions. Like some of you guys, and it's amazing. Thank you all for asking those questions, but some of the questions you got to really think about, and we can't just, write it down the moment we see it. So just letting you know that sometimes we might take, a day, maybe two, maybe more to reply, but we will get to you. So that just know that.
All right. So if you did enjoy this episode, make sure to follow on anywhere you're listening, or go and subscribe on YouTube, because we are posting these episodes recorded, not live, but just recorded our faces on a YouTube video.
We always say
Make sure
live. It's never really live.
Yeah, it's not live, but anyways. Make sure to like this episode. Make sure to follow us on Instagram and TikTok at math.physics.podcast, or add at gmail.com and send us an email, or follow us on Twitter at mathphizpod.
Decent.
Or do all of those things.
Or do
It's
all of them. Just do
all of the
them. Why
above
not?
type situation.
Why not?
So yeah, this has been episode number
43.
43.
Yep.
I'm your host, Parker.
And I'm Ray. And we will see you soon.
Bye, guys.
Ayo.